Hi everyone, today I want to show you how to implement an asynchronous MVP design for Android without using any third-party libraries. The problem was how to implement a simple decoupled testable asynchronous MVP design without using any third-party libraries that can also handle screen orientation. Before we go to the solution, I'm going to show you the project that I have already set up, and I'm going to add the GitHub repository in the description of the video. Okay, so let's go to the code. First, we have here three packages: a cache package, a common package, and a features package. Um, the cache package just contains a class cache. This is a caching mechanism for the presenters, and we're going to talk about it a bit later. The common package contains a utility class that only has a method called simulate natural latency. The purpose of this method is just to delay the current thread by a number of milliseconds specified here. Okay. Then we have a features package which contains each of the application features. I found that working by feature is one of the best ways to arrange your code. So in this case we have feature X, and for feature X we have a model, presenter, and a view. The model, not much to see here. It's just a simple business entity. This is where normally you process your data, you do all the heavy lifting, so to speak. In this case we only have three methods that return simple strings. That's it. For the presenter, we have here a presenter interface to enforce the methods of the presenters, the use cases, so to speak. This extends the presenter interface, which enforces each presenter to have this additional two methods named setScreen and getUID. These two are valid for all the presenters in all the application, while the methods in the xPresenter class are only valid for the presenter for feature X. Why do we need these two methods in all the presenters? Well, we need the setScreen method to re-add the reference during or after a screen orientation has occurred, and we need the UOID to save and get the presenters from the cache mechanism, but I'll talk about this a little bit later. Let's see the implementation for the presenter. This is again a pretty basic class. It implements the xPresenter, so our presenter should have these methods together with these two methods, so 5 methods, right? We have request action 1, request action 2, request action 3, set screen and get UUID. For each request action, in order to have asynchronous operations, I decided to use an asynchronous task. This asynchronous tasks are basically a bridge between the view and the model, and they handle all this communication between background processing, which is down in do in background, and post on the user interface, which is executed on post execute. You can consider each individual async task basically a task, something that has to be done. So basically, when I request an action from the view, the model is called and it processes the action. When this action is implemented, it will call the onPost execute, and this will post to the view. This is all done asynchronously, and all the threading stuff, all the thread synchronization and so forth is handled by the async task. The reason of execute on executor or thread pool executor is to be able to have multiple async tasks running in parallel. As you might see, all the methods are similar. So, set screen. We'll talk about this method when we'll talk about the view. This is a very important method, and also a bit later we're going to talk more about the UUID. So, if we get to the view, we have the activity. Again, it's a pretty basic activity. This has to implement the view interface. This means that our activity has to have the following methods: request action, which is a request to the business entities for something, and then to post the result after the request action has finished. This is the same case for request action 2 and request action 3. So our view, which is the activity, has to have these methods. Okay. Then, as you can see, this are really basic implement. This is a really basic implementation. So what each request action does is just request an action, and on the callback, let's call it a callback, on the post results, I'm just gonna set a string on a view. Okay. In the create view, we do nothing complicated. I just add a layout. I just get the reference to 3 views in which to post the results. Yeah, we have 3 text views. Nothing here, it's empty. Let's talk about a little bit about on-save instance states and on-restore instance state, because as I already specified, one of the issues I was having is how to handle orientation change. And what I'm doing here in on-save instance state and on-restore instance state is that besides doing all the normal stuff you should do, like saves the states of your views, is to save the presenter in a caching mechanism and restore the presenter from the caching mechanism when the view is restored. So when the view is destroyed, the Android operating system calls the onSave instance state. And this means that before the view is destroyed, we cache our presenter based on the UUID. We also put it in the out state because we have to find a way to retrieve it based on the UUID from the cache in the onRestore instance state. When the view is recreated, the Android operating system automatically calls the onRestore instance state, and this is how we restore our presenter, right? And let's first check the method cache the presenter. As you can see, this will get an instance of the cache. This is a singleton implementation for the cache. You cache the presenter for the UUID and the presenter. So this is a cache implementation. It's very basic, nothing complicated here. As you can see, here is how we cache the presenter, and here's how to restore the presenter. During restoration of the presenter, we also remove it from the cache to prevent any memory hogging behavior. Okay, let's go back to the view. In our restore instance state, like I said, we restore the instance state based on the UUID that we saved in the onsaved instance state. Okay. And very important, if you look at this method, so yeah, we restored the presenter, but the issue is that the presenter now has an old reference to the view, a view that no longer exists. So we have to restore the view reference in the presenter. So this is the reason for this, the second line. And the way I'm actually testing this is just on resume. So if I start the application, I'm using an emulator for this. Okay. When the application starts, the Android operating system will call the onResume. Okay, and this will call this request action 1, this request action 2, request action 3. This means this, let's talk about request action 1. This will go to the presenter implementation and call request action 1, which will start an asynchronous class to handle our request action 1 in a background thread. When this background thread is finished, or this request is finished, the onPostExecute methods will be called with the result from model request action, which is this string here, and now we can post the results on the user interface. And what's really nice about the async task in this case is that it handles all the threading stuff, all the issue with UI threads and background threads and how to synchronize them. This is a good wrapper, for communication between view and the model. It's exactly the same for request action 2, request action 3. Right. So let's try something else. I'm going to close the application. I'm going to start the application again. And when the application starts, I'm going to perform a screen orientation. And as you can see, everything works even during screen orientation. So this was a very short video about how to implement a very simple Android MVP, um, an asynchronous MVP design for Android, without using any third-party libraries, and that can also handle screen orientation. What I want to mention is that this is just a proposed solution. If you search the internet, you'll find a multitude of different solutions that use dependency injection and a lot of other external libraries. What I wanted to do was implement something that is really simple, something that I can use in my own applications, something that is decoupled, that has a clean architecture, that is testable, again, that is asynchronous, and without using any third-party libraries and screen orientation. Sorry to repeat myself, but all these facts were very important in the beginning before starting to actually implement this example. So, thank you very much for watching, and I hope this video was helpful to you. As I said, I will post the links to the Git repositories in the description. I will also put a link to a repository of an implementation of this pattern in just a dummy application. So thanks a lot for watching, and see you soon.